This is an example where we will solve the problem based on the conservation of energy principle. And our problem states that we have a ball of mass 0.50 kilograms and it is being released from rest. So, in any, as I've said again and again, in any physics problem, these are some of the words that you need to take special consideration along with moving at a constant velocity and other things like that, because that implies that the initial velocity at that point should be zero since it moves from rest. The problem asks you to find for the ball's velocity just as it hits the ground. Now, since we are going to approach this problem first using the conservation of energy, central to solving conservation of energy is to consider points. In this case, I will name my initial position here as my point A and the ground as my point B. Now, in the conservation of energy, or specifically the conservation of mechanical energy, we knew that from our discussion, the sum of all the energies at point A, so all of the energies at point A, is undiminished or is still the same when you take into consideration all the energy at point B. Now, at point A, there are two energies, or mechanical energy can be broken down into potential and kinetic. So I will write potential at A and the kinetic energy at A, and that should be equal to the potential energy at B and the kinetic energy at B. Now, the next thing that should be in my mind is the question of where should I set my height as equal to 0. Now, for convenience in this problem, diba, you have the choice where you will set h is equal to 0. So in this case, I find it the most convenient if I will set my h is equal to 0 on the ground. And we will see the reasoning later. So that means to say that when I try to inspect the potential energy at A, we have this value, or that should have a value since that has a height of 10 meters from the ground. And then kinetic energy at A, this should be 0. Why? Because the problem explicitly states that it starts from rest. That means to say at point A, the velocity is 0. And take note, the kinetic energy is dependent on velocity because Ke is just 1/2 of the mass, then the square of multiplied by the square of its velocity. Now, the potential energy at B, U sub B, is in this case now 0 because that is where I set my h is equal to 0 over here, because point B refers to the point on the ground. Now, kinetic energy at B is non-zero, of course, because it will have a velocity at that point. Now, we are just going to break this down. Potential energy at A will just be mgh, and that would be equal to the kinetic energy, which is just 1/2 mv at point B squared. Now, if you notice, mass is common on both sides, so I could get rid of that by multiplying both sides of the equation by 1 over m. And when I do that, clearly you will see that the mass term will cancel out on both sides of the equation. And I have, what is left with me now is gh is just equal to 1/2 vb squared. So I'm doing this very slow and step by step. So the next thing that I will do is I will multiply both sides of the equation by 2. And when I do that, I will have 2gh is equal to, of course, that 2 will cancel out over there, vb squared. Now, since I am just looking for the velocity at point B, I will take the positive root of that. So I now have the square root of 2gh is equal to my velocity at point B. So I have my velocity at point B, and I just have to substitute the values. 2 multiplied by 9.8 meters per second squared, and then your height in the problem, that's 10 meters. Of course, I will be positive since the height is measured from the ground up. Okay, so that will give you quick calculation, square root of 2 times 9.8. Okay, not 9.8, you multiply that by 10, square root of 980, right? So that will give you 14. Sorry about the noise. 14 meters per second. And if you would like to check the units, of course, the units make sense because basically you have meters times meters. So will give you meters squared over second squared. And eventually that will just be meters per second, which is your unit. Okay, so that is another way of checking whether you're dealing with the correct set of equations or you left out something. Because if this will not result to the desired equation, then my friend, you have to go back because probably you have missed something. Okay, so this is the first way of solving this one using the energy method. Now, the second method that I'm going to show to you in just one video is we can actually solve this problem based from the previous physics that you knew, which is the kinematics equation. Now, in kinematics equation, you have these four equation, and this is a long x. And the thing that you have to note is if you are dealing with y direction, what will happen is as you change your a into g, and along with that is your plus sign will be replaced by negative. So I just have it there. That will be replaced by negative because the velocity is going down. That means negative. And your x will simply, our x naught will just be y naught. Your x will just be y. Yeah, I think you get the idea. Your vox, or initial velocity along x, will just be voy. Your vy will just be, sorry, your vx rather. Your vx will now become vy. Okay, so those are things that you probably already knew, but it's worth reviewing. Now, if we try to solve this problem using kinematics, you would expect to arrive at the same answer, because basically those are just different ways of solving. Now, if I'm dealing with this in kinematics, I will set this as my y naught. So that means this is where I set my measurement along y, or my reference, and this is my y. This is the final position. And then another thing is to inspect on this equation. So clearly, in the problem, I do not know the time from the ball to the ground. It's not given, so I will try to repudiate the equation that has time. So try to get away from that. Okay, nope, nope, nope. So the only sensible equation that I could use is this equation. There's only one equation without time if you forget about that. So I'm going to use that one, equation 4. So from the kinematics equation, I have v squared is equal to v naught squared, and then minus 2g, and that would become y minus y naught, right? But the initial velocity, v naught squared, will become 0 because according to the problem, that is why you should have noted earlier that it is released from rest, implying that at this point your v naught is 0 meters per second. Okay, so we are now left with this equation of v squared is equal to negative 2g y minus y naught, and I'm just going to take the positive root on both sides. So you do that, you do that. So do not fret about the negative. It will all make sense later. V squared is equal to the square root of negative 2g y minus y naught. Okay, so from there we are going to substitute the values. So it should be v. Sorry. That will give us v is equal to the square root of negative 2. 9 on Earth is just 9.8 meters per second squared. Y, take note, your y naught is here. That means this is your 0 on your reference axis or coordinate axis if you think of the xy plane. Then any measurement below that would give negative number, right? So that means to say the height is 10. So since y is found underneath a 0, so it should have a negative value of negative 10 meters. Why not? Over there at the top is a 0. So that is why eventually you you have a positive value, because otherwise, if you have a negative value and a square root, you know from your mathematics that it will give you imaginary number, and that doesn't make sense in physics. So I is something that we don't really, or I squared, we don't really know. I think at least for me, I don't really understand its implication when we deal with with velocities that are imaginary. Okay, so when you try to calculate this one, basically this is still the square root of 980 meters squared per second squared, and that means to say this is exactly the same velocity as we found earlier, which is 14 meters per second. Okay, so in your test, it's up to you whether you will use kinematics or energy. But either of these two will result to the same answer. It's just that sometimes the energy method of solving is more convenient than kinematics, and the other way around. So it's up to you to weigh, like weigh what we should do on a specific problem. And that takes practice para makabalo ka nga, ay, mas maayo na siya solbaran using kinematics or energy. All right, so you still have two more problems to study for the test.